Yeah.
Yeah, you have to split. Yeah, and then you have to confuse. Yeah, and then you had to, and then after the first time, and then you had to move them over.
Yeah, there were only 3 problems on the homework, right? But they were something. If you guys didn't pick up the handouts, handing things out early because some people aren't coming at all next week. So what it is the semester review for the midterm that is in a month from now. And 3 old quizzes that are going to be like the quiz that you take next week. And there's one more concept to do, which I will show you today, and then that's all the new stuff. There's today's thing that we'll do on Monday. Yeah.
Do we know if the integration quiz will be on Thursday?
There's been heavy lobbying in the later classes for it to be Thursday.
So I agree with the
Okay, so are you guys okay with Thursday? No?
I can take it early. I don't.
Okay, well, so I said I would ask people, Thursday? Friday? Okay. There is 3 and a wishy-washy for Friday versus everyone else that is actually here. So it's feeling like Thursday. And the later class, the 6th period, is heavily lobbying for Thursday quiz rather than Friday.
Why aren't they heavily lobbying for Thursday?
Because they're not going to be here Friday anyway, and they don't want to miss a day of review. So they're like, I'm already like screwed, and I have to take it Thursday anyway, so I want to take everyone else down with me. So it's not a very nice thing, but you know, they're honest. They're like, I want everybody with me. Yeah.
Will the quiz be these lengths?
The quiz will be 6 questions. The 6th question is an initial value problem, like last night's homework. You will need to do U substitution somewhere. You will probably have to do some trig. You will possibly have to do a divide and conquer. You will probably have to do a voodoo, like is what we're doing today. It's very formulaic. Like you look at those 6, and the second one and the third one are very similar, but the third one was kind of angry that year. I think it was 2016. I was kind of angry that year. So that was a lot harder. This, I just wanted to warn you, integrating with logs, depending on where you move that constant, do you integrate like this thing, and it's 1/2 natural log of x plus 1, or do you integrate it with the constant in there, and by chain rule you get that, and they look sort of the same, but this is different. They are both correct. Any idea why? What?
Could you factor out the 2?
Well, factoring out the 2 here, and then multiplication inside is addition outside. So then now 1/2 natural log of x plus 1 is what I have over there. And this is plus 1/2 natural log of 2 plus c. So the c values are off by a smidgen, but it's in the unknown pile of crap, so they are equal and they look different. What were you going to say? Really question or?
No.
So just a warning, your correct answer might look really different from someone else's. Mr. Orlando used to teach this with me, and we would have completely different answers. I'm like, oh crap. And sometimes they look really, really different. Like we had to go to a calculator and check our decimals, and they were the same, but they looked super different. So just a warning, if you're checking your answers in the back of the book and it looks different than what they got, you might still be right. Great. Any issues? I wanna do integration by parts today. And if there's extra time, which it's a shortened period, I'm not sure there will be extra time, but I'd like to talk about one of the 3 problems on the homework, the wrong one that they were talking about, the e to the cosine or e to the something, e to the cosine. Yeah, okay. I don't need the whole problem yet. Okay, so just looking at these, what we've learned so far, one of them we can never do. One of them we can currently do, and one of them we're gonna learn now. What is the one that we can currently do?
Cosine x squared dx.
I agree.
Cosine x squared dx?
Yeah.
Gus,
The second one.
second one? Do I hear number 3? Okay, a vote for each one is the one, okay. So how would we do number 1? Those who felt that one.
Well, we divide. So we divide by the derivative.
Of the stuff inside.
Yes, exactly. And then
So what is the derivative of the stuff inside?
2x.
Okay, right there, that I want to divide by 2x, and there isn't a 2x there, can't do it. However, this one, so if we're choosing u is x squared, here, this becomes cosine
Oh
of
my God.
u, 2x dx is the du, whose derivative is positive cosine, positive sine.
What? No. You can solve number 1. It's just sine x squared over 2x plus z.
It isn't.
Why?
I need a 2x there. When I swap out on this one, Amir, it's cosine of u, that stuff all goes away. This is the dx, or sorry, this is du. du over 2x. I can't swap that in. I can't have u and x at the same time. I can't have miles per hour and kilometers at the same time. It's just not gonna work. You're gonna lose that satellite. So this one doesn't work. And this one, we're gonna do that. Josh?
Can we not do 1 though if we do like integrals? Just
The only way you can do 1 is if I give you bounds and you find all the little areas.
can we not do like reverse chain rule though? Like add 1, then divide by 3, and then times sine.
It's not cosine squared x, it's cosine of x squared. So I can't get that x squared.
Oh no, I thought it was cosine.
So today is integration by parts, which I lovingly refer to as voodoo because of the icon that the student made. The integral of u dv, you're not going to understand it yet, but it looks like a tanning, but it is not. It is UV rays, ultraviolet rays making you tan, minus the integral of a voodoo doll, VDU, voodoo. Get it? You don't get it. It's okay. I'll show you. All right. First thing we need to look at is where does this pattern come from? All right. Product rule. For those of you who do using these and make them look the same, pick different letters. Sasha, what is the product rule? If I want to do the derivative of u times v, what is it?
V times u prime plus u prime times v.
I know you said it the other way. I still hear my own high school teacher. First times derivative, second plus second times derivative, first. I cannot do it in any other order. Mr. Habert will get mad. Okay. So that's product rule. And the example on the front that I said we couldn't do was this thing. When I tried to do U substitution, which is the first mode of defense, it doesn't work. And I still have a product. All right, so this thing that we're gonna do is maybe what we ended up with was one of those pieces. So they're saying just checking, if I integrated, Massimo, if I integrate the derivative, what do I get out of that?
Just UV.
Just UV, okay. And those guys, I don't know what they are. Okay, little arithmetic. Okay, so the little icon thing. The integral of UdV equals ultraviolet rays, it's not a tanning bed, it's ultraviolet rays, minus the integral of, ooh, interesting, I shut down, awesome. Sorry, let me bring that. Cool, I love it when it's temperamental, as in not at all. Please don't be slow. What about U substitution?
Why can't we do U substitution for that cosine one?
Oh, look, it's so sad.
You opened up the God's soul.
Can we do U substitution for this one?
No. I doubt so.
Like, what's the U value gonna be?
X squared.
Okay, then dx is 2x dx. What do I do with the cosine?
Can't you just make it into like the sign and plug in the U value? You can't do that.
No. Yeah, it doesn't work that way. Okay, and it doesn't make a lot of sense until we try part of it. But the integral of uv prime is uv minus voodoo. It's the integral of a voodoo doll. VDU, voodoo, voodoo, voodoo. All right.
Can you go back a bit?
Oh, geez.
Okay, so
Didn't do it.
UV,
God, I'm not looking near the board.
UV minus.
And those of you who had AB last year, this is not one of the concepts covered, so this is new.
Okay, so now you can move on.
Okay, so, and to show you all the yucky things that they had under here, it's just rewriting it. And the integral of UV, the integral of the derivative of UV is UV. Okay, I just did that. All right. So there's a process, an acronym on how to choose, when you're looking at a product of two things, which one do you choose as the U value and the leftovers are the DV? LIPIT is the acronym. So if the U thing, if you see a log, choose that as U. If there's no log, and you see inverse trait, which there's exactly one on the homework, you see inverse trait, that's your U value. Then if that's not there either, the most common thing you're going to see is polynomial. That's your U value. And then if all else fails, exponential, then trait. And it's basically how to undo product rule when U substitution isn't working. You ready? Okay, so we have a product, x times sine x. Do we have log in there anywhere? No, okay. Do we have inverse trig? No, all right. Do we have a polynomial? Yes, what is the polynomial? X, all right. So here we go. My u value is the x. That means the rest of the stuff is dv. And the pattern that we were working with was uv prime equals uv minus the integral of v du. So I need du and I need v. Preston, how do I get du?
It's just one.
1 dx. Luke, I need v also, so I need to integrate this. What's the integral of sine x dx?
Negative cosine.
Negative cosine. Okay, so let's put the pattern together. This integral is u v prime, so I need u times v. So Kaylee, what is u times v? From what we chose.
X, negative x cosine x.
Negative x cosine x. Minus the integral of, Lily, what is voodoo? V du.
It's sine.
So just v du, what is that?
Oh, negative cosine x.
The negative cosine x dx. Okay. Negative, negative, I'm going to make them a positive. So I get negative x cosine x, and what is the integral of positive cosine? Positive sine. And is this a definite or indefinite integral?
Indefinite.
So what do I need to do?
Plus c.
So there we go. And those of you who are like, yeah, right. That's not true. Like, this is crap. Is there a way to check if we got the derivative right? Or, sorry, the integral right? Maybe do the derivative? So I'm saying the integral of x sine x is negative x cosine x plus sine x plus c. I'd like to check, because I don't believe it either. So Hadley, what's the derivative of that product?
Negative x times the cosine negative sine, then plus the derivative of x, which is just negative 1, and then derivative.
So first times the derivative of the second, thank you for doing it in the right order. Negative x times negative cosine, or negative sine x, plus cosine times the derivative of the first, so cosine times negative 1. Jasper, what's the derivative of sine? What's the derivative of c? What's the derivative of c? Derivative of constant, 0. So negative x plus, negative cosine x plus cosine x goes away. Negative x times negative sine x is x sine x.
What? Oh, okay.
Is that what we were trying to integrate in the first place? So holy crap, it works. Josh?
Or just like the uv part, wouldn't it just be x sine x though? Or do the negative cosine x for v?
Okay, in our setup, this argument here is uv prime. It's not uv. I believe it was Luke integrated for us to get v. dx is, or dv is sine x dx. I had to integrate to get v, which is positive cosine, which is where this guy comes from. Alright, we'll try another one.
Okay.
Forgot this one was next. I hear ya there. You get a long break for second period.
See, this is one that's very easy.
This one's very easy. I don't see a product. I see this one as very hard. But what do you, okay.
You just find the antiderivative of ln x,
What is that? I know what it is. Do
1
you?
over x dx.
That's the derivative.
1 over x plus c.
That's the derivative plus a constant. I need to integrate. All right, first thing, I don't see a product, but that this is in this section, I think I need to choose something as a u value and a dv. Do I have log? Yeah, that's the only thing I have. Well, if u is ln x, what does that make dv?
dv is 1.
It's just dx. That's awkward. All right, what's the integral of dx? 1
Plus
x, 1x.
1x.
But Amir, you got this one. What's the derivative of natural log of x?
1 over x.
1 over x dx. All right, so again, the pattern that we need to remember is the integral of uv prime is u times v minus the integral of voodoo. All right, so Josh, we need to look at this stuff that we just created. What is u times v? X ln x minus the integral of, Gus, minus the integral of what?
X, 1 times 1 over x, dx.
V times the u, well, that,
1.
so Brooke, what's the integral of 1 dx?
Dx. X.
Just x. And that it's indefinite plus c. So we're just undoing product. By being sneaky, yeah.
So would it work if you needed 1? Or would you always have to put it?
Well, I mean, dv is 1 in this case, was 1 dx.
Okay.
So Amir, to me, this one is hard because I don't see a product. And thinking of integration by parts, I would not have thought of that except that I didn't see it.
So the derivative, of the one that product is found. X ln x.
Okay, if we want to check it, so we just integrated, hooray, and all right, I wouldn't believe me either.
X ln x.
Okay, so you said do product rule with x ln x, first times the derivative of the second, plus the second times the derivative of the first, minus, and so that's my product rule, and now derivative of negative x is -1, derivative of the constant goes away. So x times 1 over x is 1, plus natural log of x minus 1, those cancel out. Am I left with natural log of x that I started with? Sure am.
On the 8th exam, how are we gonna be able to tell that we need to do this? Like, is it just to know?
Okay,
Is it-
this particular one, you gotta go through your strategies and
Do first and then.
yeah, see if U substitution works and there's nothing to substitute, and then you gotta remember the whole voodoo thing. But otherwise, like, most of them are gonna look like this. So, it's gonna be a product, and And U substitution's not gonna work. It's an x squared. Scroll the title off before you guys see it. Do I have log? No. Do I have inverse trig? Do I have polynomial?
Yeah.
Okay. Okay. So we've got to set up our stuff. Roxana, what is the derivative of 2x squared?
4x.
4x dx. Now, what is the integral of e to the x? Just e to the x. All right, cool. So Preston putting the pieces together.
The dx times 2x squared minus the integral of e to the x times 4x dx.
How do I integrate that? Give me any idea? Now I'll let you guys see the title again.
So you have to do it again.
We have to do it again. Why? Because I still got stuff. All right. Let's see, well, what are, in this new iteration, what's my new u value?
4x.
4x. And please don't use the same exact variable for a different thing in the same problem. So I'm going to call it u sub 1. Okay, so he says 4x, cool, that sounds good. Then the leftovers are the dB. And at least it's not that hard. Deanna told us the integral of e to the x is e to the x, so it still is. Derivative of 4x? 4, yep. Okay, now here it's a matter of neatness, and I see a number of you are like at the bottom of your page, and you're like, I have 2 lines left, is this gonna fit? Don't lose this stuff, it was part of the problem. Minus, and use parentheses. So the new u1, v1, 4x, e to the x, minus the integral, like, is this ever gonna stop? v1 times d of u1. Okay. I'm gonna distribute this negative sign. So I get 2x squared e to the x minus 4x e to the x. And then the integral of 4 to the x is, yep, it's the same, 4 to the x plus c. That's it. And thank you very much. I'd rather not do the derivative to prove to you that it works, but it does. So the thing that we have to show you on Monday is there's a shortcut for this. rather than having to do it a bunch of times. With exception, I have 3 minutes. I need to show you this one. This one is a chase your own tail. Don't have log, I don't have inverse trig, and I don't have polynomial. So I'm left with ET phone home. I'm left with an exponential and a trig.
These rules are confusing.
The music theories in my class, 5th period, that class is confusing. Just ask Ken, who's not here. Okay, integral of positive sine is negative cosine. All right. So this becomes the integral of e to the x sine x dx is uv minus the integral of
E prime.
okay, u prime. Okay, so I got that, and looks like I need to do it again, so I'm gonna choose e to the x again. dv is cosine. Integral of cosine, positive sine. Okay, so negative e to the x cosine x. And that was, my double negatives went away, so I'm going to add e to the x sine x minus the integral of, goodness, looks like e to the x sine x. And now I'm back to where I started, like, this is what I was trying to find. These are ones that I call chase your own tail. Because it's never gonna go away. But I can add the whole stinking integral to the other side. And I have 2 of what I wanna know equals negative e to the x cosine x plus e to the x sine x. And I got a plus c. I didn't want 2 of them. How do I get rid of the 2? Divide. Okay, so that's all. 17 seconds left. Sorry, the last one was rushed. That's the process. And there's no extra time for going over the homework, but we will do that Monday. You guys need to pick up the handouts. They're over there.